So hi guys, welcome to our class. So today our topic will be all about searching algorithms. So what do we mean by algorithm? So algorithm is a process or set of rules to be followed in calculations or other problem-solving operations, especially by a computer. So linear search algorithm is defined as a sequential search algorithm that starts at one end and goes through each element of a list until the desired element is found. Otherwise, the search continues till the end of the dataset. So we all know that algorithm is a followed calculation or a problem-solving operation. So we have the start and the end. So how does linear search algorithm work? So in linear search algorithm, every element is considered as a potential match for the key and check for the same. If element is found equal to the key, the search is successful and to index of that element is returned. If no element is found equal to the key, the search yield no match found. So for example, the array are 10, 50, 30, 70, 80, 20, 90, and 40, and the key is 30. So, also man to na to siya nakuha. So, we have the step 1. Start from the first element or in the index 0 and compare key with element array I. So, comparing key with next element array 1, since not equal, the iterator moves the next elements as a potential match. So, step 2. Now then compare array index 2 with key. So, our key is 30. So, the value matches. Since 10 is at index 0 and 50 at index 1 and 30 is in the array of index 2. So the linear search algorithms will yield a successful message since the element key is found at index 2. So here is the code for the linear search. This Java code defines a linear search class with a linear search method that performs the linear search algorithm. The main method demonstrates its usage by creating an array of numbers and searching for a specific target number. If the number is found, it will provide a message. And if otherwise the number is not found, then the array will not be presented. So this is our main function and this is the void function. So complexity analysis of linear search. So time complexity. So we have the best case, worst case, and average case. So in the best case, the might be present at the first index. So the best case complexity is 0 and 1. So in the worst case, the key might be presented at the last index opposite to the end from which the search has started in the list. So the worst case complexity is 0 n, where n is the size of the list. So in average case is 0 and n. So binary search. We also have this binary search. From the definition, it is a searching algorithm used in a sorted array by repeatedly dividing the search interval in half. The idea of binary search is use the information that the array is sorted and reduce the time complexity to 0 log n. So conditions for when to apply binary search in data structure. To apply binary search algorithm, the data structure must be sorted. It has access to any elements of the data structure, takes constant time. So also have this binary search algorithm. So how does binary search algorithm work? In this algorithm, first we need to divide the search space into two halves by finding the middle index and labeled it as mid. In finding the middle index in the binary search algorithm, we must compare the middle element of the search space with the key. If the key is found at middle element, the process is terminated. If the key is not found at the middle element, choose which half will be used as the next search space. If the key is smaller than the middle element, then the left side is used. And if the key is larger than the middle element, then the right side is used. So, the process is continued until the key is found or the total search space is executed. So this is the visualization of how binary search works. So example, we need to find 78. Since we have 6 elements, we need to find the mid. So we have this 21, 34, 43, 57, 66, and 78. This is a sorted algorithm. So from the instruction, we need to divide it into two halves. Since when it is divided, we have our mid, which is 43. So since 43 is smaller than 78, then we can use the right side of the algorithm. Then look for 78 in the right half. Then proceed to find a new mid. Since on the right half, we have this 57, 66, and 78. Then we need to find another mid, which is 66. Then since 66 is smaller than 78, then proceed to the next half, which is this in the middle of 66 and 78. Then the new mid is found, which is this 78, and element found at mid 78. So that's how binary search algorithm works. Next, we have the hash table. The hash table data structures stores elements in key value pairs where key is a unique integer that is used for indexing the values, while value is the data that are associated with keys. So hashing or hash function. In a hash table, a new index is processed using the keys, and the elements corresponding to that key is stored in the index. This process is called hashing. Let k be a key and h be x in a hash function. Here, hk will give us a new index to store the elements linked with k. So here is the visualization of hashing. So example, you have a drawer, and in that drawer, you labeled it with drink, vegetable, and fruit. If our drawer has three compartments, then we have the index 0, 1, and 2. And on the index 0, we have the value of drink, and the index 1, we we labeled it vegetable, and on the index 2, we have it fruit. Then the keys are apple, Coca-Cola, and pumpkin. So how are we gonna put it into the value? So first key, we have the apple. So from the definition, we need to compare the index of the value and the key. So when apple is compared to the index 0, which is string, the value is not found. Then proceed to the next index until the right index is found. So that's how hashing works.